Hello everyone and welcome to lesson 4 in PHP Programming. In this lesson I am going to teach you about variables and constants. The purpose of this lesson is to explain PHP variables and constants in a clear and concise manner so that you understand how they work and how to use them within your PHP scripts. So I'll get started right away. I'm going to talk about variables first. Now, variables are containers used to store data that may change during the execution of a script. A variable can contain many types of data such as strings, floats, integers, etc. In PHP, variable names begin with a $sign followed by an underscore or letter and any number of alphanumeric characters or underscores. So, I'll show you some code quickly just to make what I just said clear. Now, here we can see some valid variable names. So, essentially a variable starts with a $sign, and actually that's not really part of the name. It is just to signify that this is a variable. So, the name is actually what follows the $sign, but variables must begin with a $sign. So that just as I said, signifies that this is a variable. So here we have a variable that begins with an F, which is a letter character and of course is valid, and it's followed by two O's, which are also letter characters. So essentially it contains all alphabet characters, and of course that is valid. This second variable begins with an underscore, which again is a valid character for starting a variable name, and then it is followed by 3 alphabet characters, so of course it is valid as well. Then this variable also begins with a letter character like this one. It begins with an F and it is followed by 2 letter characters and 3 numeric characters, so all of the characters are alphanumeric, which of course is also valid. Then this one here begins with an underscore followed by a number character of 1, and then followed by 3 more letter characters, so of course this is valid. Essentially it contains 1 underscore and then all alphanumeric characters. Now this variable here is not valid. This is not a valid name, and I'm sure you can see why. It's because it begins with a number, and a variable name must begin with an underscore or a letter character. Now you can have alphanumeric characters in afterwards, so numbers or letters, as many as you want, but numbers cannot be the first character. So a variable name must begin with a letter or an underscore, and then it can have any number of letters or numbers or underscores after that. So I'll just comment out again because that's not valid. Then we're going to display these values so we can see this variable contains a string foo, this variable contains a string underscore foo, this variable contains a string foo123. So essentially they contain their names as a string. So yeah, we can see that here. This is the first variable, this is the second, this is the third, this is the fourth. Now, PHP is a loosely typed language, meaning a variable's type is determined by the data that it holds. Changing the type of data that a variable contains will change the type of data, or will change the type of that variable. So we can see here that we have a variable named var1, and we're inserting a string into it, and it's a string because it's between 2 single quotes. And then further on we're changing the type of that variable by inserting a different type of data in it. So here this variable will be of type string, then here we're inserting an integer into it, so of course it will be of type integer. Now that is what makes a loosely typed language, because in a loosely typed language you do not have to specify the type of the variable. The type of the variable is determined implicitly by the type of data that it contains, as opposed to a strongly typed language where you have to you have to explicitly set the type that the variable is, and you cannot change the type of that variable. So you could not, in a strongly typed language, you could not create a string variable and then change that variable to a type integer. You're not allowed to do that, but in a loosely typed language you are, and that is what PHP is, a loosely typed language. So here, as I said, we're storing a string in this variable, then we're changing it here to an integer. Here we're storing a boolean false value in var2, and then we're changing it to a float value here. And here we're storing a null value in var3, and then we're changing it to object, so we're inserting an object into it. And we're displaying the type, the value and the type for these, so we can see clearly what type they are and that they have changed. So this is what's inside var1 to begin with, and of course it's a string, and so it's of type string, and we're changing it to an integer 1, which of course is of type integer. And here we've inserted a boolean false value into var2, and here we've inserted a float into that variable, so we've changed its type by going from it containing a boolean false value to it containing a value of 2.5, which is a float value or double. And here we've got a value of null, which is inside var3, and of course it's of type null. And then here we've changed that to an object, so we've inserted an object into it, and of course that makes it of type object. Now with variables, it's not required to initialize them with a default value, but it's a best practice. So for example, if you're going to use a variable inside an if statement, for example, and that if statement of course can be true or false, then it's best to initialize that variable with a default value, because then you know that it's got a value no matter what. You're not relying on the if statement to determine whether it's got a value or not. You've initialized it with a default value, and then that value may change. And what you'll do, for example, is if you had an if statement, and depending on whether that if statement passes as true, you're inserting a string into a variable, then you would initialize that variable as a string. So you'll just insert an empty string into that variable. So I've got an example here. We're just getting the time of day here, hour of day. Then we're checking, is the hour of day later than 12? And if it is, we're storing this string which says good afternoon into this variable, and then we are displaying that variable. But I'm sure you can see the problem here. This may not be defined. If it's before 12, then this variable doesn't contain anything. So we're assuming that it's going to contain something, but it might not. And a better way to do things would be to initialize it with a default value. So this is what we're doing here. Greeting will contain an empty string. And then we're checking the time of day. And then if it's past 12, we're changing greeting to contain the string good afternoon. So it's going from an empty string to a string that contains good afternoon, and then we will display that value. And there's no harm here, because if it's not past 12, then the string will just be empty, so we'll be essentially outputting nothing. If you print it, it's not going to print anything because it will be empty. So you haven't got to worry about printing something you don't want to, and also you don't have to worry about the variable not containing anything. So it's best practice to initialize a variable with a default value in these situations. And as we can see, it says good afternoon here. And I have I will, if I change this, I'll just change this to show you an example. So if I change that to this time, of course hour of day is not going to be greater than 120, because there is not 120 hours in the day, so there is no way this can be true. So this will not have a value, and then we're going to try and display it, and it will emit an e-notice undefined variable notice here. So this is the notice you'll get if you try and use an undefined variable. Let's change that. I'll leave that as 120. Don't want that. Relying on an uninitialized variable is also a security risk if you have register globals turned on. Now, I took this example from the php.net site, and you can head over using this link here to have a look at it yourself. But essentially, it just shows an example of security risks that exists if you have register globals turned on and you're relying on uninitialized variables. Of course, it's because this is all hypothetical, but you may have a function named authenticated user, and if that passes, you set authorize to true. But if, for example, authorize is passing a URL by, mistake or somehow, then it could have a value of 1, and if you're using register globals, then you can't. Relying on this is not it's not safe, because authorized will essentially always have a value of 1, which will pass as true, because 1 is seen as a value of 1 is seen as true in an if statement. So yeah, and by if statement I mean if you just have an if statement with the value straight away. So of course, if this contains 1 in this example, then that will be seen as true. Now, to check if a variable has been initialized, you can use the isSet function. So if you want to know if a variable's been initialized before you make use of it or before you do some other logic, you can use the if isSet function, and that will return true if the variable has been set. It doesn't matter if the variable's empty. Let's say it can be an empty string, for etc. It just matters if it has been set or not. And yeah, you can see here we're checking if the variable has been set, then we're displaying the value. And of course, foo has been set, so you see foo is set. Foo is of type string. And that is what this does here. As well as checking if a variable has been set using the if is set item, you can do the opposite and check if a variable has not been set by using the ternary character, which essentially does the opposite. So instead of returning true if the variable is set, it will return true if the variable is not set. And you can also use the if empty function, which will return true if the variable is set and has a value. So if empty, you can use empty. Essentially, you can use the empty function on a variable that you are not sure if it's set. It will not error if the variable is not set. It will check if the variable is set and also if it has a value. And there are certain values that are considered empty, such as an empty string, an empty array, a null value. These are all values that are considered to be empty. So I've created an array of values, which it contains an integer 0, an integer 1, the null value, a string, an array, an empty array, and an array with a value. And we're looping through them and seeing, checking if they're set, checking if they're not set, and then checking if they are empty. So we can see the results of that. Item is set and contains 0, so 0, a value of an integer 0 is considered set. Item contains 0, which is considered empty. So if you run the value 0 through the empty function, then that is seen as being empty. 1, a value of 1 is seen as being set, and and the value of 1 is seen as not being empty. So if you run a value of 1 through the through the empty function, then that is seen as not being empty. Then we check the value null, which is considered to be not set and is also considered to be empty. So a null value is seen as not set and is also seen as empty. Then we check the value string, which of course is set, so it's seen as being set and is seen as not being empty. Then we check an empty array, which if a variable contains an empty array, then it is seen as being set, but if a variable contains an empty array, it is considered to be empty. And finally, we're checking an array that has a value, and of course that is seen as being set and is also seen as being not empty because it contains a value. So the array contains an item, so that is seen as not empty. Now you can unset variables, and when you unset a variable, it will have a value of null. And a null value, as we've just seen, is considered as empty. So here we are inserting a integer 1 into a variable, so we're initializing this variable here with a value of 1, an integer 1, and then we are unsetting it, and then we're checking if empty. And here, another way you can unset a variable is by assigning it the null value, which makes logical sense, because when you unset a variable, it has a value of null. So in that sense, you'll assume, and you'll correctly assume, that you can, if you insert a value of null into a variable, that it is seen as unset because it is in the same state as a variable that you have unset. So whether you unset a variable using the unset function or you insert null into it, it will have that variable, after that has happened, will have the same value. So here var has the same value as here. Both times it's null. And we can see here var contains null, which is considered empty, var contains null, which is considered not set. So yeah, here we're checking if it's empty, here we're checking if it's set, and this will check if it, as I mentioned before, empty will check if it's set and if it has a value, and it needs to pass both. But of course, if it's got a value, then it is set. And here we're just checking if it is set. Right, now we're going to move on to variable scope. Now, variables exist within a certain scope. This may be the global scope, in which case the variable will be available to all scripts, or a local scope, in which case the variable will only be available within that scope. So it means you can only use it, you can only access it, you can only reference it or do anything with it within the scope that is defined. So of course we'll start talking about global scope first. So this variable here named var is in the global scope because it's not inside the function, it's not inside the class, it is just there at the top level. So that means it is created in the global scope, as opposed to this variable here, which is created inside a function, so it is a local scope, it is local to this function. Yeah, it's not available outside of this function, it will not affect the var here with the same name outside of the function because it exists only within this function. So just quickly have a look at what that does. Right, we can see this is the global scope variable, which is available everywhere, and this is a local scope variable which is available within the function that is defined only. And here I'm outputting the global variable again just to show that it has not been affected by the local scope variable. So we're displaying this variable here, then we are displaying this variable here, then I'm displaying the global var, again, just to show that it has not been affected by this. This here is completely separate. We're not overwriting the variable here. We are creating a new local variable to this function here. So, to show you that again. This is the global variable, this is the local variable, and they both have the same name. And then this is the global one again that has not been affected by the local scope variable of the same name. Now, with a function, you can pass a variable in to the function. So here we are passing the global var, to the function. But when you pass it in this manner, it is passing it by value. So it is passing the value of that variable, which will create a new version of that variable locally to the function. So again, here, we are changing the value of a variable that is passed by value, but it is changing the value. It is not changing the global variable because we're not passing in the global variable. We're passing the value of the global variable. So this essentially, this here will contain the value. In fact, just to make that a bit more clear as well, I'll display var1. So when we're displaying the var here, it will have the global value because we passed in the global variable by value, and then we're changing the value passed in here and displaying it again, but this will not affect the global variable because we're only passing in the value. We're not passing in the variable itself, we're just passing in the value. And then I'm displaying the global variable again just to show that it has not been changed. So if we have a look at that, because he passed by value, this is the local scope variable that, in fact, refresh that. Oh. Right. That's better. Yeah, passed by value. So here, this is the global scope variable that is available everywhere. Now, and then we've passed that into the function. So this is the one that's passed in by value. Then we're changing the value of the variable that is passed in by value and outputting that. And then we are outputting the global variable, which has not been changed because we passed in the value of that variable. We did not pass in the variable itself. We just passed in the value. So we can see this is the value of the global variable displayed here. That we're changing the value of the variable that is passed in by value, and then we're displaying that, and then we're displaying the global variable again that has not been changed, and that is this here, this line here, and this line here. Now, with functions that require an argument, you can also pass in the argument by reference. So as opposed to passing in the argument by value, you can pass it in by reference. So here we are passing in the global variable, but we are passing it in by reference. So this is actually passing in the global variable. So whatever we do to that variable within this function will affect the global variable that is passed in to the function, or whatever variable is passed into that function, will be affected. So that won't always be a global variable, that could be another variable inside another function, but whatever variable you pass into the function, that variable will be affected by anything you do to it within the function if you pass it in by reference, what we are doing here. So when we pass this in, at first it will still contain its value that we defined it with here. This is a global scope variable available everywhere. But then when we change it here, this will change the value of the global variable that we passed in. So when we display it here, it will be changed. Yep, so remember, when we pass it in, it's going to have this value. Then we change it to this, so then when we display we change it to this value here, so when we display the variable again, the global variable, it will have this value because we passed it in by reference and we've changed the value of that global variable. So have a look at what that does. Passed by reference, changing the value of a variable passed by reference. So we can see that it has changed the value. That is this here. We've passed it in by reference, we've changed the value, we're outputting it here, again the global variable, and we can see that its value has indeed been changed. Now, as well as passing variables in, you can access the global variable within the function, within a function, by using the global keyword. So if you want to access a variable that is in the global scope and you're within the function, you can use this global keyword, and this then will be referencing the global variable as opposed to a local variable as it is here. Yeah, in this function, this is a local scope variable, but when you use the global keyword, we're now using the global variable named var, and we're changing the value again. So here we're inserting the string change the value of var access using the global keyword. So now when we run this function and we display the global variable, it will have changed again, so it will contain this value. So we'll have a look at what that does. Change the value of var access using the global keyword. So as you can see, that is being output here when we display the value of var, but the value is changed here because we've imported this variable, essentially this global variable, using the global keyword. So once we do this global var, anything we do to this variable will change it in its global state. It's not local to this function no more. This is actually, it's not local to this function. This is referring to the global variable. Now, another way to access global variables from within a function is using the global's super global, which is essentially a variable that's available anywhere. So this global's variable, which contains an associative array, is available anywhere. So it's an associative array of variables, so any variables that are in the global scope will be inside this item, with their name being the array key string. So of course this global variable is named var, which we've initialized here. So we've initialized the global variable named var, and then we can access that using its name from within a function using the global's super global variable, which contains an associative array, and the key is var. So any global variables, when you access them within inside the global's array, you will reference them using their name as the key, as the array key. So here we are again changing the value of the global variable named var, and we're changing it to change the value of var accessed using the predefined global's variable. And then so when we output it here, its value is going to have been changed again, and we'll see this string here. Yeah, change the value of var access using the predefined global's variable. So that value has been changed here. Now, when you include or require a file, any variables that are defined within that file will be available within the file that includes or requires that file. So essentially what that means is, and when I say any variables, of course scope comes into play there as well, but if you have a function inside here that creates a variable and you include this file, of course that variable will be local scope to that function, so will not be available here because it's local to that function. But when you create global variables, so these variables are in the global scope, and then you include this file, which we are doing here, include, or we could require it either way. It will not make a difference in terms of whether the variables are available or not. Then those variables are available within this file, as if it's essentially exactly the same as if you define them. If you define these within this file here, it's essentially the same thing. They're available automatically. So we can see these are the variables that are defined here. We're getting the date and then the time, and we're outputting them here, which essentially is why they're displayed here. Now PHP also comes with a load of predefined variables, or it has a load of predefined variables that you can make use of. We've already spoken about one, which is the globals variable. And yeah, so we'll just talk about that a little bit more. The globals variable is an associative array of built-in values as well as any global scope user-defined variables. So built-in values are values that are built into PHP and are available automatically, and user-defined global variables are any variables that you have defined in the global scope. So essentially these variables here, I've defined them myself in the global scope, so they will be available within the globals variable, and also any built-in values provided by PHP will be available in here, or not any, but some. Now this is a global scope variable, so we are creating a global scope variable here named var, and then we are displaying its value within the globals associative array, referencing it using its name. So you'll see it here, just like what I said in the last page. Within the globals array, you reference the global scope variable using its name as the key, as the array key. So this is the array key, and essentially this is exactly the same as if we just access this using its variable name. So if I, for example, was to do this, these two lines are essentially going to output the exact same value. They are referencing the exact same variable. So let's have a quick look at what that does. You can see here, yep, globals variable. This is a global scope variable. This is the global scope variable. So they're both outputting the same value here, because essentially they're referencing the same variable. Now the s_server variable is an associative array of variables with information such as headers, paths, host name, IP addresses, etc., and many more things it contains. Now just got a few examples here. So this will contain the host name. This will contain the server IP address, the server port, the server administrator's email address, the document root, the script file name. So this will be the absolute path to the current file, which is predefined variables, and this will be the project root, or the project root, the path. So essentially the path from the root folder of this site or application or project, whatever you want to call it. So here, the host name, which is learn-php.local in this case, the server address, which of course is the local host IP address, the port, the server's email address, the server administrator's email address, the document root, which is the path to the root folder, so the project's root folder, and the script file name, which is the absolute path to the current file, and then the PHP self value outputs the route to the file from the project root. So essentially you'll see that this is a combination of the document root and then the path to the file. And you can output them separately, or you can have them. You can have the absolute path using the script file name. And there's loads more. You know, I haven't listed them all, but there's a lot more that you can see on the php.net site. The s_get variable contains an associative array of information that is passed as URL parameters to the current script. So I'll make this much more clear by actually passing in some parameters. So essentially anything that is after the question mark in the URL would be passed in as parameters and available to the s_get, or available within the s_get array, and it will be in a pattern of this will be the array key. So the way it works is, this is the array key that is on the left side of this parameter, and this is the value. So it works, this is the key and this is a value within the s_get array. And then if you want to add more, you just need the AND symbol, and then again this is the key and this is the value. And that is, I'm talking about within the s_get variable, as I mentioned. So here you'll see that we are using the P1 key here and the P2, because we are passing them in the URL using the P1 value and P2 value. And these are this is the data that's passed in. So you can see contains parameter 1 and then contains parameter 2, and this will be the array key P1, this will be in the array key P2. The s_post contains an associative array of variables that are passed via the HTTP post method to the current script. So essentially what that means is a posted form. So we can see I've created a simple form here, and I'll just quickly add a value just to show you what that does. And then when I post that, we can see it has got that data that has been posted. So here I'm checking if it is set. So I'm checking if this is set, and we're referencing it by its name. So we can here see name equals submit. So then I can reference it in the s_post array using the name of the field. And then I can check. So essentially this checks, has the submit button been clicked? And if it has, then we're dumping the contents of s_post, because otherwise it will, in this case, it will be an empty array. And then yeah, we can see this has this field has a name of name, and that is what I added the value to, which I added PHP lesson 4. So then the s_post array contains 2 items. The first one is the name, which is the name of this field, and of course I entered PHP lesson 4, so that's the value. And then the second one is the submit button, because it has a name of submit and it has a value of submit, which is this value here. Now the s_files variable is an associative array of items that are uploaded to the current script via the HTTP post method from a posted form. So if you have an upload, if you have a file field within a form and you upload a file using that, then the s_files variable will contain the data about that uploaded file. So the path to the file, the name of the file, you know, some other information, if there's any errors, etc., which we will see soon. And again, I'm checking that if this button has been clicked. So this is a submit button, and this time I've given it a name of upload. So within the s_post variable, I can check if this is set, and this name is referencing this form field, which is a submit button. So essentially it means when this button, if this button is clicked, then this will be set because the form has been submitted. So then we are dumping s underscore files because we know that this form has been submitted and we're attempting to upload a file. So if I choose a file here, then I click upload, then we can see information about the file. So essentially the file name is thumbnail3.ping, so it contains the name, it contains a type which is it's a ping type, which we can see by the extension, the images of type ping. Then we can see the temp name, because when you upload a file it stores it in a temporary place for you to do stuff with, and then you have to actually save it. Within your code you have to actually save the file permanently somewhere, otherwise when the request is finished then the file gets deleted. So this is just a temporary place for the file. Then we have the error value, which is 0 because there are no errors in this case, and the size of the image. Next we have the s underscore cookie variable, which can be used to access any cookies that have been stored on the user's machine. So you can set a cookie using the set cookie method, and there's a lot of other options that you can have, like when it expires, how is it accessible, what domain is it accessible under, etc, etc. But for this example I'm just creating a very simple cookie. So we're setting a cookie using the set cookie method, and what this will do is it will store the cookie on the user's machine as part of the request. And then so we'll do that now, and then here we're checking, does the is the s underscore cookie array empty, because this contains an array, and if that array has no values, then of course it will be empty, and if it's not empty, then we're dumping the contents of it. So right now it'll be empty, but as I uncommented that line, when I make the next request the cookie will be stored, and so in the last request the cookie was stored. So then on the subsequent request that I just made, when I refresh the page, we can now get the value of that cookie, which is example of setting a cookie is what I stored, if you remember correctly. This is what I stored in it using the set cookie method. So this is the cookie name and this is the cookie value. So when I dump this array, we can see that it contains the array key is the cookie name, and the array value under that key is the value of that I set. And this is just provided by PHP or used internally by PHP. This PHP says ID value. Now we have the s underscore request variable, which contains an associative array which has the contents of s underscore get, s underscore post, and s underscore cookie. So if you can reference any of the items that are within s underscore cookie, s underscore post, or s underscore get using s underscore request. So we can see currently it has parameter 1 and parameter 2. And yet these aren't the values from these items are not always within this request. It's the way that you've configured PHP will determine the which ones are available, what settings are, by the way you've configured the PHP settings. So that is why in this case we can't see the cookie inside here, because it will be the way that this instance of PHP is configured. So it can be up to these three are available in here, but not necessarily all of them, or not necessarily any of them. Now in the s underscore session variable, it contains, so I changed the name of that, that's incorrect. Yeah, it contains this variable contains an associative array containing session variables available to the current script. Now, to store data in a session, you must first begin a session, so initialize a session, which you do with the session start function, and once you've done that, you can store data in the s_session array. So you can determine whether a session has been started by using the session ID, which will return the session ID if one has been started, or if there isn't, then it will return it's either null or false. Either way, you can use it within an if clause. So essentially, if a session has not been started, then we are using the ternary operator, so it reverses. Essentially, it returns it passes if the result is false instead of if the result is true. So if no session ID exists, then that is essentially false. It's going to return a value which either is false or is seen as false, and this will pass as true because the ternary operator does the opposite. So if it's false, then it will pass, and in which case, if it is false, so session ID is not returned, then we want to start a session because one does not exist. And once we've started the session here, we can then store session data here, which is what we're doing here. Session var example session variable, and then when we dump this, it will contain this value here. As we can see here, if you remember correctly, this is the array key name that we used, and this is the value underneath that name. So I'm just going to double check whether session ID returns false or returns null or something. Yeah, we can see, okay, it returns the session ID for the current session or an empty string if there is no current session. So it doesn't return false, but it returns an empty string, which essentially is seen as false if you use it within an if statement. So if there is no session started, then this will return an empty string, which is seen as false, so we can use it here to check if a session is started or not. Now, the s_env variable, which is and contains environment variables, essentially it contains an associative array of environment variables that are available to the current script. So here we are storing a value here in the s_env variable, and then we're checking if it's empty, which of course it won't be because we've just added this value, and then we are dumping the contents. So we can see here we've inserted an item with the array key foo and the value bar. Now you can also create environment variables using the put_env function, but variables or items created using the environment variables created using the put_env function are not available within this variable here. So you shouldn't get confused with the two, which is I've created an example here. So I'm creating an environment variable with the where the item bar contains the value foo, and then I'm trying to output it here using the s_env variable, but it will not exist inside there because essentially they're two separate things. So they're both used for creating environment variables, but they do not interfere with each other. What an environment variable created inside one will not be available inside another. So that is why we can see this here, undefined index bar, because it essentially doesn't exist. When you create, actually let me just double check that. Yeah. So when you create an environment variable using the put_env function, you must use the get_env function to access it. So it will exist under this key. So yeah, essentially you'll use the get_env and then you'll reference it using the key that you put it under here, which is produces this output here. Not sure why I've got multiple parentheses there. It's not needed. Now, the last item in this file that I'm going to talk about is the http_response_header variable, which contains an associative array of variables that contain response headers. Extra period there, that's not needed. Yeah, so essentially it means when you make a request, a HTTP request, any response headers that are returned will be available within the http_response_header function, variable, and it will be within the scope that request is created. So here we are making a HTTP request to get data from answers.com, and when we do that using the file get contents function, it means this variable here will contain the headers that are sent back from this request here. So any headers that are returned from this request will be available within this variable, but only within the scope that is created. And because this is the scope that the request is made in, and because the request is made in a local scope to this function, so it's local to this function, not in the global scope, this variable will only be available within this function. So here this will be null because we have not made a request in the global scope, we've made the request local to this function. So if I quickly show the output there, yeah, we can see this is the output here. This is the output of the HTTP response header variable from within the function, and this is when we're accessing it outside of the function, which of course it is null because the request was made within the function, so local scope to that function. As well as naming variables statically, you can also name them dynamically using the contents of another variable, which is referred to as variable variables. So what I mean by that is we can see here we are inserting, or we are initializing this variable here named foo with a string value of bar. So a string, and that string is bar. And then we're displaying that value here, and then we are using that value to create another variable. So this here will output the string bar, and then of course that name will be used for this for another variable that is, we can see because we have the $sign here, which is what you use to start a variable name. Before a variable name, you use the $sign, and then we are inserting the value of foo, so another string value containing foo. So to show you the output of that before we talk about anything else, so we can see this is the first variable that contains string bar, and then we use that value to create another variable, inserted the string foo into it. And yeah, you can also do something similar when outputting data. Yep, so we can see we're outputting the string foo and then bar with a gap in between. Sorry, we're outputting the contents of the variable foo and then the contents of the variable bar with a space in between. And then here essentially we're doing the same thing. We're outputting the contents of the variable foo and then a space in between, and then this will output the contents of the variable bar, because essentially we are this here, everything the variable that is between these curly braces will output bar, and then that will be used as the variable name. So essentially it's the same as this. These two are exactly the same, as we can see here. This is the contents of foo, this is the contents of bar, and this is the contents of foo, and this is the contents of bar, but we're accessing them in different ways. You can also access arrays using variables. So here we create an array and we're storing it in a variable named bar, and then we can use the contents of the variable foo as we did here, which we know contains the string bar, and then that will be used as the name of the variable, and then we are accessing the first item using the array key 0. So essentially this is exactly the same as this, because this here we're referencing the foo variable, which will output bar, and then we're using that output as the variable name, because we got the $sign here, which symbolizes the beginning of a variable name, or the beginning of a variable, and whatever follows that $sign is the variable name. So we're here, whatever what's following the variable name, the $sign, which signifies the beginning of a variable, is the variable name bar. Then here this symbolizes the beginning of a variable, and this will output the string bar, which is used as the name, which makes these two the same thing, and then we're accessing the first item in the array that that variable contains, which here is, let's see, I just need to refresh. Yeah, so we can see 1 and 1. We're referencing the same value here and here. You can also use variables within classes, or to access class properties, So we can here within this class, we can see within this class we've got two variables. The first one contains a string and the second one contains an array. Then we are initializing the class, so we're creating an object which will be of type foo, and then we're storing the string array within this item here. Yep, and then we're using the variable foo, which will output the string bar, to access the property. So, just to make it clear what this is doing, these two are the same. We can see that this is the standard way that you would access a property of a class if you've instantiated via instantiation. So if you've instantiated a class and created an object, this is the standard way that you would access the property within that class or object. So you just reference the variable which contains the object, then you have a right arrow, so a dash, and then a right arrow, and then the property name minus the $sign. You do not need the $sign. So this is the standard way, and then you could use variables here, because this contains a string bar. So essentially we're using the name. or we're using a string inside this variable as the property name, which is bar. So these two are exactly the same. Then yeah, so it outputs the same value because essentially we're referencing the exactly same property. We're just doing it differently. This way we're just using the name directly, and this way we're using the output of a variable which contains a string bar, which we're then using for the name. And then the same with you can do the same thing with an array. Essentially this variable here contains a string array, and then we're using that variable for the property name. So the property name here is array, and then we're using a variable, or the contents of a variable, as the property name, and then we can access the array items here. So here we're accessing the first array item, or the second array item actually, and then here we are doing multiplication of two items within the array. So we can here we can see this is outputting the second item in the array, which is 2, and then this is outputting the second item in the array multiplying the third item in the array, which is 2 multiply 3, which of course has a result of 6. Right, now we are going to move on to constants. A constant is an identifier for a value. As opposed to variables, the value of a constant cannot change during the execution of a script. Constants are case sensitive by default, and it's a best practice to use uppercase letters for constant names so they are easily distinguishable from variables. The rules for constant names are the same as variables and any other identifier in PHP. They must begin with an underscore or letter, followed by any number of alphanumeric characters or underscores. There's two ways to create a constant. You can use the define function, or you can use the constant keyword. So let's have a look at some code. As I said earlier, constant names must begin with a letter or underscore, followed by any number of alphanumeric characters or underscores, which is exactly the same as variables. And constant names are case sensitive by default. Right, so here we can see the first way of creating constants, and I say the first way because this is available in all versions of PHP, and the latter way, which is to use the constant keyword, is available since PHP 5.3.0, and in certain versions of PHP has some limitations. Now, when using the define function to create a constant, you can store a scalar value in it, so that's any value of type boolean, integer, float or string. You can also store a null value in it, or you can store the result of a scalar expression, and a scalar expression is just an expression that results in a scalar value. So it's an expression where it could be, for example, one number times multiply another number, and the result will be of type integer or float in that example, which is a scalar value, so that is considered a scalar expression. Or it could be a string concatenated to another string, which of course just creates a string, and that is a scalar value, so that is considered a scalar expression. So here we can see these are all valid names. An underscore is valid for the first character, and then it's just got letter characters afterwards, so that's fine. Here underscore is a valid first character, and then this has got alphanumeric characters, which is valid. This is just letter characters which are valid, and this is letter characters and numbers. And both of these start with a letter character, which is valid for the first character in a constant name. This would be invalid, and I'm sure you can see why. Just like the variable example, it has a number for the first character in the name, which of course is invalid, because like variables, constant names must begin with an underscore or a letter, and then after that you can have numbers, you can have other letters, you can have underscores, as many of them as you like in whatever combination you like, but the first character must be an underscore or a letter. And then we just output in these, so we'll see what they do. Constants. Yeah, we can see the first one. This is the value in the first one. This is the value in the second one. This is the value in the third one. The fourth one contains null. Now, as I said before, constant names are case sensitive by default, but when you create a constant using the define function, you can make it case insensitive. Now, I'll just say now, I would not suggest doing this because, as I said, it's better to create constant names or have constant names always be uppercase, so it's easy to differentiate them from variables. You can just glance at the code and know, okay, that's a constant name because it's all uppercase letters. But this is an option that you have, so of course it's only right that I talk about it. So here we are defining a constant, or we are creating a constant using the define function, and the constant has a name of foo2, all uppercase, and then we're inserting a string, so this is going to be the value within the constant, and then which is the second argument to the define function. Then the third argument to the define function is a value of true, which will make it case insensitive. So if we omit this third argument here, then it's false by default, meaning that the constant is case sensitive. But if we add it here, we add a true here, then it will make the constant case insensitive, and in that case, when this value is here and we've added a true value as the third argument to the define function, then the constant name will be stored in lowercase internally by PHP, but you'll be able to access that constant using uppercase letters or lowercase letters. It is case insensitive. So essentially these two refer to the same constant. This one we've got uppercase letters, and this one we've got lowercase letters. So we can see here we are printing the value within that constant, and here it's the same value essentially because we're printing it twice. Once using uppercase, once using lowercase. Now, you can use the results of Scala expressions as the values to store inside a constant when you use the define function in any version of PHP or anywhere where you can use the define function. You can always use you can always store in it the result of a Scala expression, which is what we're doing here. So this, we're concatenating two strings together. The first is the contents of the constant named foo, and then we'll just add in another string to it. The second here, which we're storing in the constant name foo4, is the result of 3 multiplied by 3, which of course will have a result of 9. Then, and is an integer, so the result is an integer. The expression is 2 integers, and the result will be an integer because both of these items are integers, 3 and 3, and the result will be 9, which is also an integer. then we are defining or creating another constant named foo5, and this time it will have the result of this expression here, which is a float multiplying another float, 1.7 multiplying 4.6, which the result will have as well be a float. And you can also store a boolean. So within this a constant here, which we are creating named foo6, it will contain the result of this expression, which will return a boolean type of either true or false. And yeah, so we'll just see the output of that. So yeah, this is the string concatenation, foo and then foo3. This is the result of 3 multiplied by 3. This is the result of what was that equation again? It was 1.7 multiplied 4.6, which results in 7.82. This is the result of the this is the boolean result, as I mentioned here. So this will return true or false, and in this case it returns true. And then yeah, so that is the results of these expressions here. Now, as of PHP 7.0.0, you can assign arrays to constants created using the define function. So before PHP version 7, you could not insert arrays into constants that are created using the define function, but from PHP version 7 onwards, you can. So here we are creating a constant named foo7, and it will have this array here, which has values 1, 2, 3, and then we are creating a constant named foo8, and it will contain the same array, but this time it's created using the range function that has items of 1 to 3, which essentially will have the items 1, 2, and 3. And then we are displaying the output, or we are displaying the these constants here, foo7 and foo8. So yeah, this is the first array 1, 2, 3, and this is the second array 1, 2, 3. So this will loop through the contents and display them. Now it is also possible to assign a resource to a constant. However, it is discouraged and the behavior can be unpredictable. So I am not going to talk about that in this lesson, but if you want to read more about it, you can go to the php.net site, which the URL is here, and you can read more about it if you like, but it's discouraged and it's not something that I do, so I'm not really going to talk about it. I mean, if a variable is fine to store a resource in, so there's not really any need to store it in a constant. But if you want to read more about it, then that is entirely up to you, and you can. There'll be more information about it online on this site and other places. If you just do a Google search, you can read up on it. Now, the second way of creating a constant is using the constant or the const keyword. Now, yeah, that is actually incorrect, so I'm going to remove that. Available as of PHP 5.3.0 and later. So here we are creating a constant using the const word, const word, and the constant is named bar, and then we're inserting the string that contains bar into it. So just we can see that is this value here. Yeah, now prior to PHP 5.6.0, when you created a constant using the const keyword, you could only assign Scala data or null to the constant. Only allowed allowed to assign Scala data or no. Oh, sorry. Let's just period these move. Yeah, but from PHP 5.6.0 and later, you can assign the result of a Scala expression or an array to a constant when created using the const keyword. So the same way that we assigned the result of expressions up here using the define function, you can do the same thing using the const keyword, but only from PHP 5.6.0 and later. But one thing that you can do with the const keyword, so when creating a constant using the const keyword, here is you can assign an array to it from PHP version 5.6.0, but when using the define function, you could only assign arrays to constants from PHP version 7.0.0 and later. So that's something that this version has that this version does not until PHP 7. So from PHP 5.6.0 to PHP 7.0.0, you can only assign arrays to constants using the const keyword to create the array. So we can see here we're just doing some expressions, pretty much the same as earlier, and yeah, so we can see that's the result of the string concatenation. This is the multiplication of the integers. This is the multiplication of the floats. This is the if. This is the expression if one constant is higher than another, which will return true or false. In this case, returns true again as earlier. And then yeah, so that's the output of this code here. Then here we are assigning an array, so we're creating a constant named bar6, and it's going to contain an array that has 3 items: car, bike, truck, and we're looping through all of the values here, and then you can also output the values one at a time, or some of them and not all of them. You can reference them using their array key. So of course arrays are 0 indexed, so this is referring to the first item here, the array key of 0. The array key of 1 is referring to the second item, and the array key of 2 is referring to the third item. So that is this here. This is where we're looping through them and outputting them all using the display values function, and then this is where we're outputting them individually using the actual array keys here, 0, 1, 2. Now, unlike variables, constants do not have scoping rules and are available everywhere. But there is a thing as a class constant, which we'll move on to next, which are essentially the same thing as normal constants, but they're specific to a class. But when talking about normal constants, they are available everywhere. So when you create a constant, that constant will be available within a function, even if it's defined outside of the function. Essentially, it will be available wherever you want to use it. So here we are defining a constant named foo_bar, and we're displaying the value, and then we have a function here named foo, and we're displaying the foo_bar constant again, and this will refer to the same constant because they do not have scoping rules, as I just mentioned. So we can see here outputs the same value because it is the same constant it is referencing in both times. Now there are a few ways to check if a constant is defined. The first way, and the way that you will pretty much be using, is using the defined function, which will return true if the constant is defined, and it will return false if it is not defined. So it's a simple true or false, which of course is great for if clauses, because if you want to know if it's true, you do something; if it's not, you do something else. Simple as that. So here we are checking if the constant foo_bar is defined, then we're displaying it. We're running this line of code here, otherwise we're running this line of code here. which produces this output here, foobar 93. Foobar 92. Yeah, you can also use the defined, the result of defined directly. So here we are checking if foobar 2 is defined, and of course this will return true or false, and then we're using that directly. So we're not using it in an if clause to output something if it is defined and something else if it's not defined. We're actually using the result returned by the defined function, which will either be true or false, and we're using this var export function so we can actually output that value. So we can see that is what outputs this false here, and the line number 98, because foobar 2 is not defined. Now you can use the constant function to get the content or the contents of a constant. It will return null if the constant is not defined. So essentially we can see these two lines here are the same thing. So here we are outputting the value of foobar here by using its name, and then here we are using the constant function, which will, and we're passing in the name foobar, so the constant foobar, and this will return the value inside foobar if it is defined, which is, and then that value will be passed to this function and output. So essentially these two do the same thing. Yeah, foobar, and this is the line, foobar, and this is the line number. So that's what this does. Contents of foobar, and then we're using the line number as well. And you might be wondering what this is here. This is I will explain what these are later on in the tutorial. So, but essentially they're predefined constants that are provided by PHP and output the line number that they exist on. So here it will output 101, I mean here 102, here 98. Essentially it's just a way of accessing the line number dynamically within your PHP scripts. Now, because the constant function returns null if the constant isn't defined, then you can, in theory, you can use it in an if statement, because an if statement, if you just use if and then an expression that returns null, that null value is considered false, because within an if statement, within an if clause, a null value is considered false. So if this returns null because the variable is the constant is not defined, then that is seen as false. So essentially it's the same thing as an if defined, using the define function, but you wouldn't really use it this way. The first reason is that the define function is that is its purpose. Its purpose is to check if a constant is defined or not. That is what it's set to do. So that is what you'll use, because that's its purpose. That's why it exists. Yep. But I just wanted to show you that you could use this way if you wanted to. And the second reason why you wouldn't do this is because, or why I don't suggest doing this, is because it will cause an E warning, couldn't find constant error if the constant isn't defined, which you may not see because you may not be seeing those errors. If you're on a development machine, you probably will, but not on a production server. But again, it'll be sloppy coding and just not a good way to do things. But I did want to show that it is possible. And yeah, so this will return null because this isn't defined. It will return null, and we will see that here. As I mentioned, it returns a E warning, couldn't find constant error. And yeah, foobar is undefined. Sorry, no, foobar. Yeah, foobar is undefined. That should say foobar 20 is undefined. Yeah, foobar 20 is undefined. That makes more sense. You can get all defined constants using the getDefinedConstants function, which returns an associative array of containing all of the constants that are available in the current script, so which are defined at this point. So wherever you call the getDefinedConstants function, it will return all of the constants that are defined at that point in an associative array. So you can also, if you wanted to, you can also use that to check if a constant is defined or not. And that is what we're doing here. So this variable will contain all defined constants because it has it contains a value returned from this getDefinedConstants function, and then the constants will be inside that variable, which contains an array. So it will be, the constant name will be the array key. So if you wanted to access the constant, you would use the use the constant name as the array key. So here, if the constant foobar is defined, then it will exist within this variable here under this array key. And that is what we're doing here. Foobar 116, because we're checking, is it defined? This pass checks as true because it is defined, and then we're displaying the contents of it here on line 116, which is what we're seeing here. Now we're going to talk about class constants. Class constants are just like regular constants, except for they are declared within a class and are therefore accessible within that class only, or through that class only. Now within a class you should use the const keyword to create constants, because if you use the define function, then it will create a constant within the class. If you use the defined function to create a constant within a class, it will attempt to create that constant globally, essentially, because it will not attempt to create a class specific constant. It will just attempt to create a normal constant. So if that constant has already been defined, then that will result in an error, because you can't redefine constants. That's one of the rules of constants. Once a constant is created, cannot be redefined, it cannot be undefined or anything. It exists for the duration of that script. Once it's been created onwards, that's it. You cannot modify its contents, you can't change its contents, you can't undefine it or anything like that. It's things you'll do with variables you cannot do, which the name is pretty much self-explanatory. That's why it's named constant, because it's constant. Once it's created, it is constant for the duration of that script. So yep, and if you do define a constant within a class using the define function, then that constant will exist outside of the class as well, so it's not really considered a class constant, because a class constant is a constant that is specific to each class, or specific to the class that it is defined within. So because of that, you should use the const keyword if you want to create a class specific constant, which is what we're doing here. So here we are creating a class specific constant. So in fact here we are defining a constant named foobar outside of a class using the define function, and then here we are creating a constant inside a class using the const keyword, and these are different constants here. So this is a class specific constant, and this is just a normal constant. So if we look further down, we're displaying the value of the constant that is created here named foobar, and then we are using the object, we're using the class foo display constant function or method to display the contents of the class constant of the same name foobar here. So this will output the foobar constant, this will output the foobar class constant. Yep, so constant 17, constant 22. So this is the foobar constant, this is the foobar class constant. Now, I've purposely added a line of code which will cause an error. See, here we are defining a constant using the define function named foobar2, and this is not inside of a class, this is in the global scope. Even though scope doesn't exist for constants, I'm still going to refer to it as a global scope just so we can be clear about that. Essentially I just mean created, not created with inside a function or a class, created at the top level. And then here we are attempting to create a constant within a class using the define function, and as I mentioned earlier, this will try and create a constant that is available through all levels, so not a class constant, an actual constant, and it will error. Because of that, it will error because the foobar2 constant has already been created. So this is trying to recreate it, which it can't do, because as I mentioned, once a constant is created, it cannot be changed, cannot be removed, cannot have its value changed, cannot be redefined or anything. It exists for the whole duration of that script and it cannot be altered in any way. So this is going to cause an error. Unlike creating a constant within a class using the const keyword, which creates a class specific constant, which so it can have the same name as a normal constant. When using the define function inside a class to create a constant, that will not attempt to create a class specific constant, it will just attempt to create a normal constant. So if a constant with that same name already exists, then it will error, which is what will happen here, and which is why we are seeing this error here. Notice, or this notice here, constant foobar2 already defined. So I'm just going to comment it out now so we can get rid of that error. This will work because it will create a normal constant named foobar3, and there are not any constants with that name already, so it is perfectly fine. Although if you want to create a class specific constant, this will not provide that functionality, or this will not do what you want to do. So once I create this constant here using the define function inside a class, this will be available everywhere, not just within the class but everywhere, because it creates a normal constant, not a class specific constant, which is why I can display its value here. That's why class constant 930. This is where it's defined on line 30. Now, you can access class constants statically, which is what we're doing here. So you just have the class name, the colon, then the constant name. As of PHP 5.3.0, you can use a variable to reference a class, or a variable containing an instantiated class. So when I say reference a class, I mean reference the class name. So here we are inserting the string of foo to this variable, into this variable, and of course foo is the class name, and then we are using that variable to reference the class name. So essentially this here is the same as this, because this contains the string foo, so we're using it as the class name foo, and then we're accessing the class constant. And here we're using an instantiated object of type foo. So this is essentially this class instantiated, and then this is the constant within that class, so you can access it that way as well, which we'll see we're doing here and here. PHP provides magic constants, which are predefined constants available to every script that PHP runs. Exactly which magic constants are available depends on the extensions that are available within your version of PHP. When I say version, I don't mean version number, I mean within your actual build of PHP, because it could have been built with certain extensions compiled within it, and also you can make certain extensions available dynamically depending on how you've configured PHP. So of the magic constants, there are 9 that change their value depending on where they are within your script. And you might see this one here, which I was talking about earlier, which essentially just outputs the line number. So wherever this constant here exists, underscore underscore line underscore underscore, it will output that line number. And this constant here, underscore underscore file underscore underscore, will output the file that it exists within, which in this case is magic constants. And this constant here will output the directory that the file that this code exists in is within. So essentially, just to say that in a bit more of a clear way, the parent directory of the file in which the line of code resides, or this constant resides, which in this case is the lesson 4 directory. So I'll just show the output of those 3. The underscore underscore line underscore underscore constant is on line 16. The file constant is within the magic constants.php file, and the directory that the file that contains the dir constant is within is lesson 4, and it is the complete path to the directory, not just the actual directory itself, but the path to that directory from the root folder of the system. This here, in fact, I'm going to move that actually because we can't really see it there, can we? Which is no good. Right, that's better. This here will output the name of the function that exists within, which of course is bar in this case. This here will output the name of the trait that exists within, which is bar as well in this case, with an underscore b though, with an uppercase b, as opposed to the function name bar that is all lowercase. Then we have a class named foobar, and this constant here, underscore underscore class underscore underscore, will output the name of the class that it exists within, which is foobar in upper camel case in this case. And then this here, underscore underscore method underscore underscore, that constant will output the name of the method that it exists within. And again, we can't actually see this that well, can we? So just going to move the comments so we can see them better. Yeah, this will output the method name, and it will be the fully qualified method name, so it will contain the namespace, the class, and the method. This will output the namespace name, So this underscore underscore namespace underscore underscore constant will output the namespace name that it exists within, and this constant here will output the class name. So essentially to the left is the actual class name, and then you have 2 colons, and then you have the word class, the keyword class, or the constant class, and that will output the class name. It will be the fully qualified class name, so it will contain the namespace name and the class. So any namespaces, any sub namespaces, and the class. And yeah, there are, in fact, I'll show you the output of that quickly before I say anything else. So this is the function foo bar. As we can see, it's got the class name and the function name. This is the class, which we can see it's got the namespace name, which is foo, and then it's got the class name, which is foo bar. This is the method, which has the namespace name, then the class name, then the method name. So as you can see, the difference between these two, if you've watched any of my other tutorials, you know that a method is just what a function is called when it's inside a class. So when you're outside of a class, you say variables and functions. When inside a class, you say properties, which means variables but within a class, and you say methods, which means functions but within a class only. So they have a different name when they're outside of a class and inside of a class, but essentially they're the same thing. And that is the difference between the function constant and the method constant. Is the method constant will output the namespace name, the class name, and the method name, whereas the function outputs the, actually no, is that correct, or is that might be incorrect actually. Let me just check something. Yeah, but that is when it's within a class. So when you use the function constant here from outside of a class, but within a function of course, it will output the namespace name and then the function name, which we can see here. Namespace name, function name. But when you use it within a class, it only outputs the function name, which we can see here, construct. It does not output the class name or the namespace name. So that is a difference between function and method. The function and method constants is the function constant outputs the function name, and the method constant outputs the namespace name, the class name, and then the method name. Just remove that. Yeah, this is the name of the trait, so it's got the namespace name, then the trait name. This is the name of the namespace foo, and this is the class name that is created here, or is obtained using this constant here, which is the namespace name and then the class name. So it's fully qualified. And fully qualified just means it provides the absolute path to, or the absolute name to that class. So it would be the namespace, any namespaces in any sub namespace, any class name. So you know when you reference it that way, you know exactly what you're referring to. There's no ambiguity. Because basically, essentially you could have a class name that is in the global namespace, and then you can have a class name that is within a named namespace, and it can be a bit ambiguous which one you're referring to. That is why you would use the fully qualified name, so then you know exactly which one you're referring to, because you have the namespace name and then the class name. So there's no ambiguity into which one you're referring to. And there are lots more predefined constants, such as these ones mentioned here: PHP version, PHP OS, PHP int max, etc. You know, loads more. You can see a full list of them here on the php.net site. And we have reached the end of the video. I hope you found this video helpful. I hope it gave you some information that you didn't have before and you've learned something from it. If you have gained some knowledge from it and you found it useful and you think there's someone else you know that would also find it useful, then I would appreciate it if you shared the video with them. And if you haven't subscribed to my channel, you should subscribe now if you want more videos like this. If there isn't a sequel to this video yet, don't worry, there will be soon. So this is lesson 4. So if you can't see lesson 5 on my channel, it should be there within the next few days, because as I said in other videos, I'm trying to make at least one video a week. So yeah, don't worry, there'll be something more there soon. And until next time, take care.